Welcome to the seventh session of Module 4. In this session, we are going to discuss about optimization goals with respect to quality of service, energy efficiency, scalability, and we also discuss about distributed organization. So first optimization goal is quality of service. In Monet, the quality of service interpretation is usually we are going to measure with respect to throughput or delay or jitter. High perceived quality of service is necessary for multimedia applications. In wireless sensor network, quality of service is more complicated. So here it is dependent, the quality is dependent on event detection or event reporting probability, event classification error, detection delay, probability of missing a periodic report, approximation accuracy, tracking accuracy. All these are responsible for quality of service. And the related goal is robustness. Network should withstand failure of some nodes. Second optimization goal is energy efficiency. So what is the energy that has been spent for correctly receiving a single bit? And these counting all the overheads in intermediate nodes, what are the payloads that is present, so that will consume some amount of energy. Okay, so that energy, it is better to reduce that energy required for the payload bit transmission, that should be reduced, but actually what the bit is required, for that bit we can spend the energy. So energy per reported event, after all information is important, not payload bits. This is especially important for WSN. Actual information is needed, so we can spend the energy for the actual information. Unnecessarily, we are not supposed to spend on payload bits. And energy efficiency, that is related with the delay or energy trade-offs. So we can say that, so energy, why it is important is, so it actually influences on the network lifetime. There are several definitions for the network lifetime. The first definition is, so we can call that the lifetime of the network when time to first node failed. So if the first node failed, that means that that particular network lifetime is over. That is the one definition. The second definition is network half-life. How long until 50% of the nodes died? That is the second definition. And how long, that means a time to partition. So as the nodes keeps on dying, so the bigger cluster, so that will be divided into smaller clusters. So when that is going to happen, when you are going to do the partitioning, so that is called the network lifetime, another definition. Next is time to loss of coverage, particular area. So if we are unable to cover that particular area, so that is called the network lifetime. And time to failure of first event notification. So if some event that is unable to notify that, so then we call it as a network lifetime. That is the network lifetime of that particular network. So that's why The energy is important and we are going to store it in the battery, and this is limited, so that's why we should design a network, and we should spend the energy only for the useful bits, not for the payload bits or the recurring information if it is going, so we can avoid it. Okay? So those are all the research topics. Next optimization goal is on scalability. So depending on how many number of nodes you are using, so the network should be scalable. Uh, at high efficiency, network should be operational regardless of number of nodes. Okay, we don't exactly know that how many number of nodes we are going to use for a particular application. It depends on the applications. Okay. In monets, we can use tens to 100 numbers of nodes. In WSNs, tens to thousands, maybe more sensor nodes we can use. So it is requiring to scale to large node numbers has a serious consequence for network architecture. Might not result in the most efficient solutions for small networks. So we should carefully consider actual application needs, and then we can deploy the number of nodes. So then the scalability that is appropriate and that is scalable network. Okay, so unnecessarily we are not going to deploy more number of nodes, or we are not going to deploy less number of nodes for the particular application. We should check the application and we should deploy the appropriate number of nodes. Next is distributed organization. Participants in Monet or WSN should cooperate in organizing the network with respect to medium access or routing. So here centralized approach is alternative, but it is not feasible. Okay, so it will hinder scalability and robustness. So what is the potential shortcoming is it is not clear whether distributed or centralistic organization achieves better energy efficiency. Centrally, if it is processing, when taking all overheads into account, so we are not clear whether the centralized organization achieves better energy efficiency. So what is the option for that is we can go for the limited centralized solution. So some of the nodes we are going to choose or elect for local coordination or control. Okay, so and that electing nodes we can rotate among the nodes that are present in the network. So the from that node, so centralization that can be achieved, not fully but limited centralization, so that may be useful. So this is about distributed, whether which is better, distributed organization or centralized organization. We can choose in between distributed and centralized organization. That is called a limited centralized solution we can use in WSN. This is the reference I have used, and thank you.